All right. Today and tomorrow, so Monday and Tuesday, since it's a short week, this is going to be our one activity for this week. And we're going to continue with our discussion about forces in motion and really try and concrete our understanding. And so, what I wanted to do was this forces and motion PhET lab. So we've done a couple PhET labs before, and so the first thing you're going to do is try to become familiar with the lab itself. So following directions, use the forces in motion PhET lab to help you answer the following questions and follow the step-by-step directions. So throughout this formative, I have numbered and bolded uh, the step-by-step directions. Okay, so as you go, you're going to answer a couple questions, and then you're going to see some more directions. Okay, then you're answer some more questions. Okay, and then have some more directions. So you're really going to want to look for these numbers that are bolded to follow the directions, and hopefully they will make sense. And if they don't, then I would really encourage you not to get frustrated, but to simply, email me or ask me so that I can help you get this situated. So here we are. So the first thing you're going to want to do is open the PhET lab. So you click this link, it should open. I believe HTML, right? Goes through the web browser and not anything like a Flash player. So it should work on the Chromebooks. Fingers crossed. I'm always worried about that. Um, but then here we are. We have net force and motion is what we're really going to focus on uh, with our questions today. And I haven't quite decided, but we might eventually look at friction and acceleration in future activities. Okay, but really we're going to be again working with the net force. We've now done a couple activities with net force, so hopefully we're feeling good about that. But I really want us to draw some conclusions around it and then look further at motion and its relation to force. So, again, this is it. So, when I read the first step, open the lab. Second step, select the net force simulator. Okay, so that's right here, net force. And here this is. So now looking at number 3, select all 3 boxes in the top right corner. And so that's sum forces, values, and speed. So I want to select all of these. Then step 4, add different combinations of people on both sides. Run multiple times and try to make observations. And the next hint I'll give you is uh, try to read the questions ahead of time. That way you kind of know what you might be looking for. So the first question is going to be what is needed in order for motion to occur? And try to use the term net force. So again, if I'm doing this, uh, I can click and drag at all these people out here if I want. Then you see that I see a sum of their forces. It tells me that there's a left force. Okay, and if I hit go, it accelerates to the left. Okay, and then I can hit return again, and then you can add people to the right. Okay, it tells me it's 350, 100, so there's still a 250 newtons to the left here. And I can see how that changes it, right? Uh, so again, try different combinations, see what it does. That's a little bit slower, might be an observation that I make. Okay, and then I'm thinking about question 1. What is needed in order for motion to occur? And just real quick, I'll give you a hint. Couple things you can do. Sum of forces equals 0. It doesn't even let you go. If I add this and this, okay, sum of forces, and it doesn't move. Ooh, okay. So again, you can try different things to figure out this answer, but again, try to use the term net force. Then what is the relationship between net force and acceleration? And so the sentence frame I've given you here is, as you increase blank, then blank will happen. Okay. As you decrease blank, then blank will happen. So a couple examples. Okay. As you increase net force, then acceleration will blank. Or as you decrease net force, then acceleration will. Okay, so that's kind of how I would think about that and word that. Question 3: what do you need to have in order to achieve the greatest rate of acceleration? So it's really tying in. Are you understanding how net force and acceleration are related? Okay. And so if you wanted to create the most acceleration possible, one of these answers should hopefully make sense based on the lab, and you can test it out in the force and motion lab. Next, so directions continued. At the bottom, select the motion simulator. So if I go back to the lab, right here at the bottom, you should see motion. So if you click that, now you can see the scenario changes. Select all the boxes in the top right: force, value, masses, and speed. So again, I got force, value, masses, and speeds. And so basically, this is giving you as much information as possible. I can see the mass, I can see the speed. Okay, we're going to apply a force, and now you can see the label of the force and the arrow. Okay. Oy. And again, this one's a little different, so you might play around with it, figure it out. There's a pause and play button. You can skip step by step if you really want to, and reset. One thing I'll say about the reset button that kind of annoys me a little bit, it takes away your check mark. So you're going to need to recheck these each time you reset. But then use the slider for applied force to help you answer the following questions. So in number 4, question 4, I give you another set of directions actually. So run the simulation twice with 100 newtons of applied force to the right. But one time is going to be with the 50 kilogram box. And the second time will be a 200 kilogram box. So you're going to do this once each. And then you're going to compare. So which object had the greatest acceleration? So again, it's got 50. The best way to get to 100, I believe, is you click this twice. You can see that I have applied force of 100. Okay, and I'm observing the acceleration. I can kind of see it here. I can kind of tell based on how fast it's moving. Okay, I go ahead and reset that. I double click these again, and I swap it out. So I got to click it off, and I put the refrigerator on. Again, I just double click the newtons, go boom, boom, right there. And you can see a difference. It's accelerating, but differently, right? So then you select which one had the greatest acceleration, which one accelerated faster is what that's asking, right? And then question 5, what do you think? Why did the two objects not accelerate at the same rate when you applied the same amount of force? Okay, you applied 100 newtons of force to both. So why did they not have the same acceleration? Go ahead and do your best to answer that. It's a short answer, so I want you to kind of try to explain it as much as you can. Question 6, what would you need to do in order to make the box and refrigerator accelerate at the same rate? Okay, so we know if you apply the same force, it was not the same. So what would you need to do differently? Would you need, well, I won't give any ideas, okay? Think about what would you need to do to make the acceleration the same. And that then leads us down to here, where I want you to solve the problem, okay? So it is this, hint, this scenario here will help you solve this answer for 6. Okay. But then you're also answering it again here. What force would you need to apply to the box and the refrigerator in order to get them both to accelerate at 2 meters per second? Okay. This is not going to be necessarily done in the simulator, but by your calculations using this equation. Okay. Again, you know the mass of the objects. You know the acceleration because you're trying to make that the same, 2 meters per second. And so then by doing that, you will get the force that is needed to make that a true scenario. Okay. Number nine, or question eight, but step number nine. Now run the program and complete the following. Okay. So I want the refrigerator on the skateboard. So boom, I'm going to reset it as well. Boom. Okay. Refrigerators on the skateboard. I want you to quickly add 500 newtons of applied force to the right, and then let it run until it reaches about 35 meters per second. And I'll be honest with you, it's a little tricky. Okay, so it doesn't have to be perfect, but if you let it run to 40, uh, then it kind of like stops the program a little bit. So um, quickly do your best to try and stop it at 35 meters per second by watching the speed, and then quickly add it to the left and just watch what happens. Okay, so again, I'm here and it said 500 newtons, right? So I'm going to go boom, 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 as quickly as I can. 500 newtons. It's accelerating. I can see it. I'm anticipating now, ready for 35 meters per second. It's now 20, 25, 30, and I switch it to the left as fast as I can. And I'm making observations. Okay, I see that the speed is slowing down. This guy is still moving to the right, though. I'm applying all this force to the right, and it's still moving to the left, and now it's still moving to the right, and now it's changing and accelerating, speeding up again. Okay, so a couple observations there. Multiple choice. What happens when you change the direction of the force that is already moving? Okay, it looks like I need to fix that, so I'll give you a fourth option there. And then number 10. Okay, now run the program and complete the following. You're going to do the same exact thing, but with a box. So if I reset this, the box is on there. Boom, boom, boom. Again, this is going to be a little trickier. It's going to go a little faster, I'll tell you that. So you do that. Okay, look, it's already at 35. Boom, 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 boom. I got to switch it. Okay, again, now it's accelerating already to the left. So it a very similar motion, but different, right? So compare what just happened with the box to the refrigerator in the previous question. Was this any different? Yes, it was. So how was it different? But also what was similar about it? Okay, and explain how it was similar. Then I want you to hypothesize. Why do you think the objects did not stop immediately when you changed the direction? Again, it was going to the right, you quickly shifted it to the left, and it took time before it could change direction. So, why do you think that is? And then, two, why do you think the refrigerator took longer to stop? Okay, what is different about the refrigerator and the box that would make the refrigerator take longer to change directions? Okay, so again, I really want you to start thinking a little deeper about the forces and the motion, how that's related to acceleration. Okay, and then we're kind of we're really observing a different factor that we haven't talked about yet. So with these last two questions, if you're thinking about it, you might be discovering our next concept on your own. Okay. Again, though, hopefully you have some fun playing around with the simulator. Answer the questions. If you don't understand the questions, let me know in class. Always happy to help. We have Monday and Tuesday to work on this. I really don't want to make it due over the holiday break. But of course, if you turn in late, I'm not going to dock you down if it's turned in late. But this will be due technically then on Tuesday because I don't want you to have homework over the holiday. And so that being said, I hope you have a great week and a great holiday. Okay, and good luck.